Hi everyone, my name is Rob Russell and I lead transition efforts in Novaa. We're excited to be here today to tell you about a project that we have been working on in partnership with NAVSEA. But before we dive into the details, we want to put the bottom line up front, and this will be the most important thing that we will tell you today. We have successfully broken the current design paradigm of conventional electronic arrays. What this means for the Navy is that we can now dramatically bend the acquisition curve on multi-million-dollar sensor arrays and provide alternative options for high-performance, multifunctional, low-swap-C arrays. This advance is a leap ahead in product development. It will provide the Navy with a simple, affordable, and extensible electronic array that now enables mass use of a high-performance C4 ISR solution across virtually all platforms. So what was to date prohibitively high-value applications such as satellite communications, radar sensing, and electronic warfare that were restricted to high-end ships is now for the first time employable in fit, form, function, and cost on a wide range of naval sea and air platforms. So specifically, over the next few minutes, we're going to introduce our innovative electronic Reflectarray. Ideally suited to the Navy, this is a low swap and low cost array that combines the best attributes of active electronically scanned arrays, or ESAs, and parabolic dishes, whilst resolving their inherent issues. In developing this technology, we employed a new phase-shifting design that dramatically reduces signal loss, and unto itself can be employed as a standalone, ultra-low swap beam steering capability on very small platforms, such as unmanned or attritable systems. We'll introduce the Reflectarray by first taking a few minutes to highlight this significant underlying advance. The outcome of these developments enable low-cost arrays that are high-performance, low-swap, scalable to virtually all platforms, and extensible to any required C4 ISR operation. In short, what we are presenting today is technology that is broadly applicable to the majority of Navy and Marine Corps programs. Before we discuss this work, we'd like to very briefly provide some context on who we are. Our business and technical focus is directly centered on developing low-swap, low-cost beam steering technologies and ultra-wideband multifunctional arrays. We're experts in this area. This is our niche, and every project that we have worked on throughout our 5-year history has resulted in highly innovative and often unprecedented outcomes, continually advancing the state-of-the-art in antennas. Our work spans all environments: land, sea, air, and space, both for government and commercial use. What differentiates us from other companies is that we provide antenna solutions at low swap and low cost without conventional trade-offs in performance. Many others have sought this same goal, yet with the Navy's help, we've achieved it. And now, this technology is the future of electronic scanning arrays. On to the Navy challenge. Still deployed on numerous ships is the venerable AN/SPS-49 radar seen here. It's a large, mechanically pointed air search radar. The Navy has asked us to develop a new electronically scanned antenna for this system that eliminates mechanical pointing in elevation and thereby significantly reducing the maintenance burden. Critically, this must be done affordably, within the current size and weight envelope, and without any reduction to system performance. And lastly, develop the added capability to implement multiple electronic beams, effectively upgrading this from a 2-dimensional to a 3D radar system. The reason why this challenge exists is that current antennas, such as AESAs, reflectors, and waveguides, are not entirely optimal devices. In particular, conventional electronic arrays are simply not low swap nor low cost systems. These continue to suffer from unacceptably high power consumption and thermal buildup, requiring complex cooling systems which make today's ESAs incredibly expensive and restrained to use on high-end platforms. Reflectors, such as the SPS49 we just looked at, retain large and heavy mechanical drives, also rendering them high swap and slow to steer in a dynamic environment. And similarly, waveguide devices, such as the SPS48 array, are only suitable for radar applications, and then are still challenged by poor range resolution, and their delicate tuning requires periodic and expensive depot-level calibration. In contrast, our solution circumvents the limitations of these conventional arrays to advance a new and widely extensible design that eliminates or reduces these unwanted trade-offs. Before we discuss the Reflectarray that we're developing for the Navy SPS49 replacement project, it's important that we take a moment to look under the hood and highlight a key underlying advance embedded in and enabling our solution. Of several innovations in the Reflectarray, a major breakthrough that we've achieved is in extremely low-loss phase shifting. What this means is that we can eliminate the complex and expensive circuitry driving the cost of conventional AESAs without reducing performance. Importantly, this innovation unto itself can also be employed as a standalone ultra-low swap, low-cost option, extending multifunctional electronic beamforming to platforms of all scope and size. This means we can now provide high-performance electronic arrays for use on everything from unmanned attritable systems up through large-scale shipboard radars. This achievement is so significant that it represents a new class in phased array antennas. The underlying innovation in phase shifting is embedded in our Navy SPS49 radar replacement work. Here, we are developing an extremely low-loss electronic scanning reflectarray to meet the Navy requirements you saw earlier. In this case, we have, as requested by NAVSEA, eliminated mechanical pointing and elevation and provided rapid electronic beamforming that has reduced side lobes, improved beam shaping, and supports multi-beam 3D surge capability. It is impressively high power tolerant, and yet of a simple, lightweight, and affordable ruggedized design that will significantly reduce maintenance and life cycle costs. Importantly, the key takeaway is that whilst developed to replace the SPS49 radar, this design is scalable and flexible, tailorable to fit, form, and function, and therefore, in different profiles as needed, is ideally suited for wide deployment across the broad range of ships and platforms throughout the Navy at low cost. In short, it is a low swap C, multifunctional, common workhorse array. The project is progressing extremely well and poised for a rapid transition to the Navy. Over the course of 2024, we'll be looking to finalize a full-scale prototype test, bringing the technology to TRL7 and readying it for operational testing. Concurrently, we'll be seeking bridge opportunities and a full Phase 3 partner to deploy this technology. A key point to emphasize is that risk is low. The initial development periods are all but complete. The project is on schedule and on budget. So to pause for a moment and recap just a bit, we're introducing a common, scalable solution with high-performance features that present impressive size, weight, power, and cost savings over conventional ESAs. This flexible design centers on a fundamental new approach in phase shifting, enabling lightweight, solid-state, and low-loss arrays. Leveraging this phase shifting innovation, high-gain electronic beam steering can be realized through a simple architecture. The collective performance characteristics, to include ultra-wideband and multiple beam capabilities, are unprecedented and represent the leading edge in ESA research and development. Of significant operational value, enabling multifunction, high data rate operations on a single shared aperture, this highly extensible low swap C array enables mass use of satellite communications, radar, and electronic warfare on virtually all platforms, and thus a viable transition path for near ubiquitous C4 ISR operations, not only in the Navy, but across other services. We're extremely excited about the enormous potential to transition these innovations into the Navy. This is a problem-solving technology. You no longer need a multi-billion-dollar program to outfit ships or other systems with radars. This capability is fundamentally accessible to all relevant programs within and across the Navy and Marine Corps. For example, there's now little reason why every ship in the Maritime Sea Lift, especially in the Combat Logistics Force or expeditionary roles, can't have multifunctional electronic beam steering arrays on any platform in their fleet. So why would you want to consider this technology for your program? A couple of reasons to spur some thought. Cost reductions, especially dramatic ones, and with high performance gains, cannot be ignored. So service extension projects, modernization programs, block upgrades, midlife updates, replacements, and consolidation of the operations on electronic scanning arrays are now extremely cost-effective options, without trade-offs in performance. Opening the box to shift pertinent C4 ISR operations to unmanned systems is also now a reality that can be achieved with commensurate electronic scanning arrays that are relevant in fit, form, and function to these systems. Offboarding these tasks leads to near ubiquitous connectivity and the realization of new concepts of operations, enabling pervasive surveillance, communications, and electronic response. With unprecedented reductions in size, weight, power, and cost, scalable, common workhorse arrays can be cost-effective additions to platforms that may suffer from conventional swap restraints. This can serve to enable new capabilities on platforms such as electronic warfare or cost-effective redundancies or ISR backups to high-end systems. In all, the value of this technology runs broad and deep. You can start to see and believe that this low-cost beamforming capability provides the transition path for unconstrained ISR operations in the Navy and across the Department of Defense. To summarize, the key takeaway is that we're now introducing new low-cost options for high-performance, multifunctional, low-swap electronic beamforming arrays. These are widely extensible technologies, scalable to virtually all naval platforms, and relevant to the majority of PEOs and programs in the Navy. So do come talk to us if you have any questions whatsoever. We're always delighted to explore how we can assist Navy operations and how this technology can fit into your project. Thank you for your time.